All right, welcome back. We are game 3001 in the summer 2021 semester, and it's week 6, part 2 of our broadcast. And here I want to talk about assignments 3 and assignment 4, actually. So assignment 3, again, was released today, so it should be available to you. Again, you cannot see assignment 3 or 4 unless you join assignment 3 groups and assignment 4 groups. So I'm presenting this to you, I'm showing it to you. But again, in order for you to see the full assignment, you need to have joined a group for assignment 3 and assignment 4. Let's take a look at that. So let's start looking at assignment 3 first. So this is due July 25th by midnight. And again, the assignment is about decision making. For this assignment, you can work alone. I highly don't recommend that though. And with a partner or 2, and the group member, a total group member size of up to 3 members. Okay, so I will allow up to 3. In this assignment, some things are marked as mandatory, which means you have to get these done in order for you to do well on the assignments. So the way it works is this: you have your start scene, which is kind of free. Okay, and I mean that it's like the exact same scene that you've seen so far in assignments 1 and 2. So no issues there. But once we get into the play scene, this is where it gets a little bit more interesting. So in this case, you're going to include something called a node class. And the node class is something that we're going to be looking at. Okay. The node class is very similar to our tile class that we've created so far. But what the node is going to have, as an example, it's going to have it's going to be obviously going to make a series of nodes. Each of the nodes is going to be a place where you can, an actor or an agent can walk. Okay, so think about those as nodes to traverse. You can use some kind of vector list or other data structure for your a collection of node pointers. So, and a lot of times what we want to do is we want to use nodes for traversal. Okay, so ensure it says that you select an appropriate actor sprite. Again, when we say this is your own sprites. So please don't use any of ours. If we share something with you in class, these are examples. We'd like you to make your own, kind of game on your own with your own assets and everything else. The actor will be able to move in any direction by responding to key presses, WASD. So that's the actor could be your player in this case, right? Or by using the left stick on the gamepad. Okay, so that's one thing that we're going to allow. Gamepad access again for assignment 3 and 4, right? Gamepad access, by the way, is built into your SDL engine. I've kind of built that in for you guys. So if you plug in a gamepad, it will work. We talked about that in the very first day. So it's not going to take a lot for you to get an Xbox controller or a PlayStation controller working there, or some other third-party controller. You want to create an interesting map again that you overlaid on top of these nodes. You can also use a tile map set. When we say nodes, notice there's no grid anymore, and I'll talk about that in a second. Play scene must include background music. Please make sure, even for assignment 2, that you set your background music to a volume to a reasonable level. One of the things that we get sometimes is overpowering background music where we can't hear you talk right in your video. If it's that loud, guys, it's too loud. Bring it down, or at least give the option for the player to reduce it through IMGUI, right? Or even turn it off. Add simple sound effects for actions and triggers in the play scene. Okay, so for the requirements, what you also need is a debug view. Again, you can have keys to do this, or you can use IMGUI. We've made it so that you can use key access just in case IMGUI is too difficult for you to figure out. And what we want to do is display things like line of sight rays. We kind of did line of sight rays when we did the whiskers for obstacle avoidance, right? And there's going to be these two things that each of your AIs are going to have. Some kind of sensing suite that's going to include line of sight and a detection radius, right? Also, sometimes what we want to show is collider boundaries. When I say collider boundaries, that means the collision boundary for your objects, okay? And node points. So we'll talk about that. The user will be able to activate certain effects by pressing various keys. As an example, for example, the P key is pressed. The base enemy's movement will be toggled between idle and patrol. So we're going to be talking about this coming forward. The player will also have animations and sound effects. Remember, we talked about that you shouldn't do this project alone. Well, you shouldn't do it alone because there's a lot involved. Player animations alone, plus sound effects, could be quite challenging to do on your own. In addition to all the things that you need to do for the game, the player has got to have combat capabilities. So the ability for them to do close combat, melee, or melee combat is something that you want to do, and you need animations for this, as well as range combat. So some kind of shooting. Okay. Notice we don't tell you have to shoot like a bullet. You can shoot a bow. You can fire. You can launch a grenade. You can do all kinds of stuff. But you need to have both close combat and range combat capabilities. All right, so that's something that you're going to do. For range combat, you will use this fire and forget projectile, so you don't have to worry about tracking. It's not going to be a some kind of seeking projectile. You don't have to do it that way. Although, as an option, I'm sure that making a seeking projectile would be kind of cool too. In other words, using pathfinding. Player's orientation is set to follow the position of the mouse pointer or moving the right stick on the gamepad. So think about this as a top-down tank game kind of idea, right? The player health bar. Okay, so that one thing that we were introducing in this assignment, the third assignment, is a health bar object that's going to basically display the health status of the player in real time, okay? Again, there's a couple of ways to do this. You can make a large health bar that's displayed on your user interface somewhere, or you can make a health bar that follows the player. It's up to you. Your play scene will include a progression bar or a progress bar, almost like that gives you things like feedback for the player to let them know how far they are in the game. Okay, score label or other control that will display how many enemies are still active in the scene and how many have been eliminated, okay? And then you're going to have obstacles in the game. Your play scene will include at least 4 obstacles that will stop the player and the enemies from passing through them. And these obstacles must be solid and impassable, and obstacles will also block enemy line of sight. So if there's an obstacle, the enemy can't see the player behind the obstacle. They know where the last position was of the player potentially, but they can't see the player. However, they will not block enemy detection radius. So think about enemy detection radius as a smell radius or a sensing of another kind. You can hear the player. The enemy can hear the player, or smell the player, sense the player in some other way. Maybe it's just radar, right? Whatever it's going to be, but it's there's 2 radii, right? There's 2 components to the sensing suite: the line of sight. So can I see the player, or kind of like a point of view, as well as can I hear the player, see the player, detect the player in another way in a specific radius. So those 2 things, every enemy will have that. And that's what it says here in the base enemy setup. Notice it says base enemy. Well, because assignment 3 is your base enemy. Assignment 4 is something that you're going to extend the base enemy and create a couple loadouts, which we're going to be talking about soon. So think about this again as a larger assignment that we've broken up. And that's why we put all these details in place. Your game will include a base enemy class. The base enemy object will move patrol along a predetermined path of nodes. Notice that there isn't a requirement for a grid. And I'm going to show you an image of this in a second. The base enemy game object will have a health property, which will be displayed in a health bar, similar to the player's health bar. Okay, so imagine that I have a base enemy class. I've already talked about a health bar. I mean, if you think about this, I could create a health bar class that I reuse for the enemy, right? The health bar class could just show any objects, any agent's health, right? Which is something that you could do. All right, base enemy should have animations and sound effects. The base enemy will have line of sight capabilities, so you will need to calculate and keep track of whether or not they have line of sight with the player. And there's different techniques on how to do that, okay? Raycasting is one. You will need to account for any obstacles that may block line of sight in this calculation, and the result can be stored in some kind of Boolean object in an instance property of the enemy. So for example, it's going to keep track of, do I have line of sight or not? Okay. There's also going to be base enemy detection radius. Again, the second component of the enemy sensing suite. Okay. As what it's going to have. And just like line of sight, it can be stored as a Boolean. So there's some kind of radius, and as when the player crosses that radius, it's like a collision detection. It's not going to cause them to stop. This detection is going to be more of, is the enemy within, or the player within my sensing radius or not? It's a kind of a yes or no question. And then again, use Git and GitHub for source control. Your submission, you'll have to make a little video and all that kind of stuff as before. And the whole thing is worth 100 points, and it's broken down into a simple rubric like this. Again, I'm going to be using for assignment 2 my other rubric, which kind of uses the same criteria and breaks it down one step at a time. Alex may do things slightly differently, but all these things we're going to be considering when we create a rubric for our assignment marking. So what the heck is this? What are we doing? Well, it really culminates in assignment 4. So let's take a look at assignment 4 and see what that looks like. So we made assignment 3, we made a base enemy. Assignment 4 is going to be due August 15th. And you're like, wow, I got so much time. August 15th. Yeah, you get no time, right? Assignment 3 and assignment 4 are way more challenging to do than assignment 1 and 2. Programming wise, from a programming patterns perspective, from a data structure perspective, there's just so many things that you have to keep track of for both. This one, so the first one is decision making, right? So do I have, it's almost like a setup for this one. So assignment 3 sets up everything for assignment 4. Why? Because assignment 4 is all about behavior. All right, so you need to have assignment 3 working in order for you to have, assignment 4 even viable. So notice it says assignment 3 integration. It's a mandatory prerequisite. If you don't have a working assignment 3, you really can't do assignment 4. Okay, so just letting you know about that. So way ahead of time, I'm telling you this so that you don't sit there and say, I just want to do assignment 4 and I want to do assignment 3 and assignment 4 together. Yeah, no. You need to do assignment 3 separately, hand that in, then build on assignment 3 and do assignment 4. You're going to have, for requirements, a bunch of AI actions. So your AI can now do more than just patrol. It'll allow you to do patrol from assignment 3, some kind of predetermined path that it's going to follow. And then here are some additional actions it can take. It can move to player. So it requires line of sight, this action, and it'll move toward the player using some kind of arrival steering behavior. Notice how we're incorporating our steering behaviors from assignment 1 in here. And it'll stop at close, so that'll be the arrival point instead of being right on top of the player. And when they are at close combat distance, they can obviously do an attack. But for now, play the move animation and related sound effects. So there'll be some kind of move animation related to moving to the player. Okay. Close combat attack. It requires line of sight and close combat distance. So when the AI is close enough to the player to attack, they need obviously still to have line of sight and to be in the right range. And when they do that, they can perform the close combat attack and the related close combat attack animation and sound effects and start damaging the player immediately. Okay. Now, one thing we didn't put in there is that do they have to face the player? And we've had that question before, and the answer is yes. So the player, the AI will have to face the player in order for them to attack. Okay. If the AI is not facing the player, even though they're within close combat distance, they can't attack. All right. So that's something that is not listed here, but it's something that we're probably going to be asking for. Flee. Move away from the player, avoiding obstacles, and leave the scene. So when does that happen? When the enemies the AI enemies are damaged, they're going to try to flee. Notice that there is another steering behavior here, right? Move to line of sight. Find the closest node to the player with line of sight, right? Use obstacle avoidance. This is from assignment 1 again, along the way, and use this seek steering behavior to move. So notice there's like a lot. This is building on assignment 1 a lot. as an example. But we can also use assignment 2 for finding the shortest path to the player. So what's the shortest path to the player? Well, let's find the closest node. Closest node is shortest path. That's pathfinding, right? So again, it's using all those things together. It's kind of a culmination of everything. If Frain says I'm doomed, no, you're not. It just means that you have to do what I've asked you to do, which is combine with other people that can assist you, right? Next, what we want to do is we want to move to range. So again, requires line of sight. We use a blend of separation and cohesion steering behaviors. Remember, separation and cohesion allow us to keep far enough away, separation, but close enough that we were in range to fire. So we want to be almost like at the perfect distance is what we want the move to range animation. So we want to keep away from the player. In other words, this enemy might have a close, a distance weapon like a rifle, and it's not really great close up, right? So they want to keep their distance in order for them to trigger something. Or maybe they have a bow and arrow. Again, not really great close up. It's definitely the player. If the enemy was attacking close up with a player that was in range in close combat, they would have a disadvantage, right? And we wouldn't want to have that happen. So we want to keep them far away from the player, keep their distance, kind of stuff, right? And almost like this distance keeping idea is what separation, a blend of separation and cohesion is, right? Move behind cover. Find the closest node to the player that does not have line of sight and move there, right? So again, closest node, that means the assumption here is that you're going to be using pathfinding to get there, and then you're going to play the move animation and related sound effects. Wait behind cover. Okay, the enemy, now that they've found they're behind cover, the enemy must be behind cover. That's a condition, right? And then the enemy will wait for a random interval and then leave cover. So why? So you pop behind cover as the enemy, right? Because you've just got hit, let's say, and then you're going to wait X number of seconds and then pop out of cover again and try and attack the player, right? You can perform a ranged attack, requires line of sight and the enemy at the appropriate range, so distance keeping again, right? And you're going to play the ranged attack animation. We're going to generate a projectile object, some kind of, it could be using an object pool, it's up to you, that moves towards the last position of the player. And if a projectile hits the player, then apply damage to the player. So that is, again, a fire and forget type projectile, right? So those are all the actions that the enemy can do, but when do they do them? It's based on their decisions. And there are two different enemies we're going to ask you to do for assignment 4. The first enemy is a close combat enemy. Again, what we're going to be doing is we're going to make a subclass, all right, so a child class of the base enemy superclass from assignment 3. So that's why assignment 3 is super important, to get done. The close combat enemy will include the following behaviors. It's going to start in patrol action and continues this action until they have detected the player by either line of sight or if the player is within their detection radius. Okay, we talked about those two things. That's part of their sensing suite, right? If the player is in their detection radius and, notice the and, they do not have line of sight, so I can feel the players around, or I have a radar, they're in my radar, but I can't see them, right? If I'm on the AI, then perform the move to line of sight action. Try and find the closest node to get into line of sight using pathfinding, okay? If the close combat enemy has line of sight, then perform move to player action. I know where the player is, move closer to the player through the nodes that I can see. If the close combat enemy has line of sight and is within close combat distance, perform the close combat attack action. And then if the close combat enemy's health drops below 25%, they will perform the flee action. Okay, so that's what they're going to do. So notice that's how the close combat enemy works. Ranged enemy is similar in that they start patrol and so on, and they might move to line of sight, but they're going to choose to stay within range and then do a ranged attack. Okay, again, if they're damaged below 25%, they will perform the flee action. Two things that make the ranged combat enemy more challenging is this idea of moving behind cover, how to figure that out, and then the idea of waiting behind cover. Alex is going to go into more details on how to do this kind of stuff, but at the end of the day, the ranged combat enemy is slightly more tricky to put together and make work than the close combat enemy. Destructible environment. That is going to be worth 5 points. And so you're going to choose at least two of the 4 obstacles we've asked you to put together in assignment 3, and you're going to make them destructible. So they're also going to have health bars so you can destroy obstacles and get through. You may elect to only show the health bar when they're getting hit. Otherwise, it's going to cause a little bit of clutter in the user interface. You can also do that for enemies as well. I find that always showing the health bar of enemies and all that stuff all the time, especially enemies that haven't gotten hit, as an example, might be a little bit too much clutter. So maybe what you want to do is, hey, if the enemy has less than 100% health, then show the health bar. Otherwise, don't. Kind of thing. Enemy respawning is something that's going to happen. If an enemy flees the scene successfully, then a new enemy will respawn, and you can randomize which type, whether it is either loadout, whether it's close combat enemy or range combat enemy. All right. You're going to create a winning condition. So the way you can win the game for assignment 4, and I'm using air quotes again, if the player defeats both enemies without either of them fleeing, then you win the game. Display a label object that reads "you win" or something similar. Maybe you want to take them to another scene, like the end scene. Display a restart button that allows the game to restart. Okay, so that is the win condition. Again, use Git and GitHub for source control, and make sure you create the proper submission as we talked about before, and a little video about how this works with you and your partners. Again, this one is worth 15%. Okay, so the first one is worth 10. The second one was worth 15 for a total of 25% of your final grade for assignment 3 and 4. All right, so that's a lot of information. So what the heck am I looking for then for all this? Because there's a lot of details here, and it's hard to visualize just by telling you what it is. Let's look at maybe a diagram. I used this diagram before, and maybe I have that diagram, and maybe I don't. I think I do. Here's assignment 3 and 4. All right, so I'm going to bring this up in a diagram that looks like this. So imagine you have a screen, right? And the screen is basically, if you look at these blue objects as nodes, let's say nodes that you can traverse, and again, I made them random sizes, but it doesn't really matter. They can be the same. You can have different enemies, right, as an example, and different enemies will have, a different kind of, the ability for you to sense the player. And there's really 4 cases. The first case is if this is the player object down here, the player is going to have their own health bar, the enemy is going to have their own health bar, and this is by assignment 4. Does the enemy have line of sight here? Well, no, because I can't draw a line array that goes from the enemy object all the way to the player. There is some kind of obstacle that is in the way. Okay, so then this case, the player doesn't have line of sight, and the player is not within the enemy sensing radius. So the enemy will then continue to patrol. And maybe it's going to patrol from one node to the other. It's going to use pathfinding to do this, right? A predetermined set of paths that's going to keep going. And every time it travels from one node to the other, it's going to continue to detect if it can see the player or not. If I move here as an example, and let's just use our annotation for this. We'll use a green line, right? So from here to here, do I have, just a second, do I have line of sight, from this node to the player? Well, no, because it goes through this obstacle. But maybe between those nodes, somewhere between there and this node, there might be line of sight in between. And what I mean by that is, you're moving from here to here. You're constantly detecting if you have line of sight. Do I have line of sight here? Yeah, in this case I do. So maybe there's going to be another node. I mean, I made this pretty sparse, this map, but you can have additional nodes here. What we don't want you to do is make a grid. Okay, so this is a case where we don't want grids. We want you to use nodes. And then why nodes work a little easier when it comes to things like decision trees or other kind of structures than a grid. It can work with a grid as well, but the data structures can be quite complex when you apply a grid to a tree. So again, there's no line of sight here. So this is case number 1. Case 2, you don't have line of sight, so line of sight is false, but radius is true, right? So here, line of sight is false and radius is false. So in this case, we can detect the player, and now what I'm going to do is I'm going to try and move to line of sight. So if I'm here, if this is where the enemy is in this node, then I want to find the closest node that has line of sight with the player. So is it this one? Is it this one? Which node is the closest node to the enemy? Is it this one? Is it this one? You know, which one? This one doesn't have line of sight, so it's one of these three. There's also this one, right? Because we want to look at all nodes that have line of sight. And most likely it's going to be maybe not this one because it's so close, depending on how you do your line of sight checks, but maybe it's going to be this one. Okay, so I move from here to here. When I move to here, depending on the type of enemy it is, if it's a ranged enemy, I might stay there, right? Or I might move back. I might move from here because maybe it's too close. Maybe I move from here to here, right? So I move over there, I see the player, uh-oh, let's move back there if I'm a ranged combat enemy, right? As an example. So that is base case 2. Base case 3 is I have line of sight, but the player's not in my radius. So I'm able to see the player, but I can't attack the player. I can't actually, I'm not close enough, or I can't feel the player. I can't hear the player or smell the player, let's say. I can only see them, right? And then case 4 is I have both. I'm here, there's nothing blocking me. I can both hear the player, see the player, and players in my radius. I can do something to the player. I can decide if I'm a close combat enemy to attack the player, move closer, or I can decide to keep my distance keeping, and move out, right? So those are the 4 types of cases that you're going to run into with your enemies. And notice that we have these 4 obstacles. By default, you're going to start off that with assignment 3, and then 2 of these obstacles you're going to give the same kind of health bar, if you will, that you've given the player and the enemy. So it's kind of a very high level drawing of what it looks like. You can't cheat. Yeah, Andre, they can't cheat. But the main idea is how, in our case, to connect it to machine learning. Well, again, it's not machine learning, it's AI. Machine learning is a totally different topic where the enemy would learn, as an example, when it makes mistakes. So let's suppose that you had some kind of overmind that was controlling your AIs, and they were just getting smarter and smarter as you continue to kill them. All right, so that's something that you can include later. All right, so this is neat, but is there some kind of example that I could show you? Maybe there is. And I'm going to see if I can bring up an example here of from a previous project. And I'll see if I can run this, by the way. Again, I ran this several semesters ago. This is from 2020, right? So a bit more time. But the great thing about this, and I'm just waiting for a resharper to finish this up, is this was written by a student, Herman Hum. I think this is a pretty good example of what can happen. Okay, so I'm just going to not show you this stuff necessarily, but let's take a look. Let's just retarget my solution to make sure that it works for me. So again, I'm just like before, whenever you look at another solution, let's retarget this one. So here we are, retarget solution. And then we want to change it, make sure it's x86. And let's see what runs and how this looks. Hopefully you'll be able to see what I'm showing you here with the game. So again, this is Herman's solution from a couple years ago. So let's see how this looks. And I say a couple years because it's kind of at the beginning, almost 2 years ago. And I thought it was a pretty good one, so I wanted to show you this with you and see what you feel about it. So here's his game, right? You can see that the player can move around. It has the 2 different enemy loadouts, right? He's actually created a third that does both, right? There's also traps in the game and a bunch of other stuff that he's added in here all together, right? So the player's health is down here, and you can see that the enemies all have their own health bars as well. I can attack this way. I can also launch a bullet for the enemy, so I can attack the enemy that way as well. But you can see how I'm getting nailed by the other enemies as I go forward. It's quite a challenging game. You can see that there are obstacles that are destructible, and right, and that's the kind of game that he kind of put together with simple tiles. Okay, So that's an example of of how it works, right? So it's really cool. Yeah, it is. The range guy is definitely OP for sure. But that's the kind of game that you can kind of create with this thing. So I think it's a great opportunity for you guys to explore, the framework that we share with you, as well as some of these concepts. And it's totally doable, something that we can do. He used a state machine for his final solution, but it doesn't mean that you have to. You can definitely use a decision tree or a behavior tree structure for yours. Okay. Any questions around assignment 3 and 4? I'm sure there are going to be, guys. Even if there's not now, Alex is going to go through the details with you yet again. This is not the last time you're going to see these things, but I wanted you to see the stuff that's coming forward. There's going to be a lot, I think, that to prepare for, and I think it's really exciting to see what you're going to come up with for assignment 3 and 4. So one of the things that I recommend to you is kind of combine with people that are interested in AI, that want to create something that's really cool, and everything else, and how it's going to add in. The best thing is adding this into your to your game production game. How do I add AI to my game production game? This is the question you should ask yourself, because I'm going to join you in game production in the second half. After next week, Philip will be leaving and I'll be taking over. Right. So for the people who are in game production, I'll be with you guys, and I'm looking forward to seeing how you're going to apply AI in your games. All right. So any questions around assignment 3 and assignment 4? Again, as a recap, assignment 3 then is your base game, is your base stuff. You're just kind of putting together your map. You're putting together your base enemy. You're putting together the data structures and everything you need to support assignment 4. That's what assignment 3 is about. Assignment 4 is like a mini game that you're going to make, right? Where you have a game, and where the winning condition is, it's kind of how long can I live before, the only way I can win the game is if I defeat all the enemies, before they flee the scene, right? Notice that in Herman's example, he also had an AI that had both capabilities, both the close combat and ranged capabilities, right? And that's really cool, but it's not required. So he went kind of above and beyond. That's why I'm showing you that game, to show you what you potentially could put together if you were interested in doing something like that. I think it was a great solution to our assignment 3 and 4 problem. So now I'm looking forward to seeing what you're gonna put together for your games this semester. All right, going back to this, again, keep track of this. So again, assignment 3 is out today, and it's going to be due week 11. So that's the week of July 19th. I believe it's the July 25th is the actual due date at midnight. And assignment 4 is going to be due August 15th. That's Sunday, August 15th at midnight. It looks like it's far away, but there are a ton of things that you need to review to get you up to speed. But there's nothing that can stop you right now from collecting assets, sounds, and everything else that you're going to use for assignment 3 and 4. Again, if you're not in game production, so if you're someone who is coming back to this course from before, and you're not part of the game production group that's taking that with Philip, it behooves you to get going on this ASAP, because you're going to have to collect those assets, those animations, and so on anyway, and you should test all that stuff out that you can add into the game before the end of semester. Okay, that's it for this video. I'm going to stop recording, and I'm also going to say I'm going to stop this whole session. The next time we're going to get together for lab, and during lab, we're going to cover a bunch of stuff, and this is what we're going to cover today in lab. We're going to adjust the heuristic function. We're going to do that find shortest path thing we talked about last week. Display the path list. Maybe we're also going to create a spawn object method and do some kind of random generation to test the pathfinding algorithm. Okay, that's what we're going to be doing this week. So I'm looking forward to seeing you guys in about an hour and a bit. Okay, any questions before we stop for the day? I know there's going to be, and if you don't have questions right now, it's totally fine. Remember that I'm going to be around, even though I won't be with you for the second half of semester on AI. I'm still around. You can always, hit me up for any kind of questions you might have, or Alex. I can help you guys out. I want to help you guys to be successful for this thing. And anything you do, when it comes to coding and understanding the framework this semester is going to help you next semester when we hit physics. Okay, guys? Thank you so much. And again, I'm going to stop recording this right now, and I'll see you guys during lab. You're going to have questions for the entire